I think week 9 is related to power management. Yeah. So just kindly confirm that week 9 is related to the power management or block diagram we will cover in the first one. I think charging subsystem.
Yes, sir.
Okay. Then I think then after that amplifier design, then battery charging profile, and then after that I think the battery charger. Okay. Yeah. So these particularly topics will be discussed. Can you week 9? Okay, but battery charger circuit also. Battery charger circuit. Okay, so these five particularly. Now in the last week, if you remember that we start with the basically system. We discuss the Bluetooth system. In this Bluetooth system, there are different six subsystems. One is the battery subsystem. Then power management subsystem, battery or basically charging. Then power management. Then sensors, LED, mm, RF, I think so. And one is one more subsystem is there. Okay, so total six subsystem. Now after that we start with the charging subsystem. Charging is the very important. Okay, because when we design a system, if we are going to design a system, the first of all two important terms is one chip selection and second is the performance is the important parameter. Okay, a simple example is that when you are going to purchase a laptop, what you are observing, the processor, okay, uh, RAM, hard disk, STD, okay. So After that, if we go with the more details, so first of all, you observe the processor. So under, like for example, I select the i7 processor. Okay, I select the i7 processor. Now the second thing is that under i7, I just go the 8th generation, 10th generation, or nowadays 13 and 15 generation will be going on. Okay. Similarly, when you go select the DD RAM, the first is the you select the 8 GB RAM, but after that you select the DDR4, DDR3, DDR5. Okay. Similarly, if you are selecting the SGD, so SGD you select that you require 250 GB. Then SGD, DGDs, NVD, NVID, M.1, okay, NVID, M.2, like this one. Okay, so I think you all aware about this one. Yes or no?
Sir, what is the DDR and the NVID M1 and 2?
Basically, this is the type. Okay, that is the generation DDR3, DDR4 is the generation. They basically decided on the basis of what clock frequency they are produced and what is the basically supporting system they will use. According to this one, RAM will be decided in when you select DDR3, DDR4, and DDR5. Okay, you just go about that one. The DDR will be having a the particularly speed. I think DDR4 have a around 3600 MB per second is the speed refresh rate, and DDR5 is around 7200 MB per second. Okay, so this is the refresh rate. Okay, so how much refreshing rate is there? How much is the better is the performance? Okay, similarly, NVID M.1, M.2, this is the basically on dependent on clock frequency or the supporting parts. Okay, so you can check on the net. I am not going in the more detail about that one. Okay, so this is a simple laptop configuration. So the two important thing is then which chip you select. Okay, because like for example, you purchase a i3 with a fifth generation laptop. Okay, that particularly the laptop will be support Windows 10. Now, if you want to upgrade into Windows 11, what happen? This laptop not support Windows 11. So basically, chip selection in on basis of your hardware integration. Okay, like for example, in i3 fifth generation, you can't go more beyond the 8 GB RAM. Okay, you can't go more than the 8 GB RAM. If you want a 16 GB RAM, either you have to increase the generation or you have to increase the processor. So every particularly processor, everything will be have a limitation. Like previously, if you are aware about 5 to 6 years before, so core to dual processor are over core to dual. Okay, they support maximum 4 GB RAM. If you install, they will support the 8 GB, but they will slow down the speed. Okay, if you operate a 2 GB RAM with 2 TB hard disk, okay, it will be slow down the performance. Okay, so every particularly chip you select, every particularly things you select, the important thing is that hardware integration is possible or not. Okay, so similarly, if we go about our parts, so the chip will be decided on the integration of hardware. Okay, whereas if you are talking about the performance, so there are the multiple parameters on the basis of that when we analyze the performance. Like for example, the chip is stable or not, Second, what is the form factor? Third, if you are going to the performance, the performance, the temperature. Temperature is basically under the stability. Okay, so stable form factor. Then mm, price. Okay, and then if we go with the yeah power consumption. Okay, form factor, price, power consumption. And these are the mainly parameters that will be affect the performance of any chip. Okay. So how we define the stability?
Sir, the both are in the left half of the explain.
No, that is the basically a transfer function. I am not talking the transfer function. I am talking about the electronic subsystem. Okay. So the stability will be dependent on durability. Okay. For example, mm, I purchase one battery. Okay. I purchase one battery, two different batteries from company A and company B. Okay. The power rating is same, voltage same, and current same. V and I both, all three parameters are same. Okay, one battery operate for 10 hours, one battery operate for 24 hours. Which one is more stable, more durable? That is will work on 24 hours. Okay. Second thing, same battery A and B. One will be work for 10 hours, but the thing is that the temperature will be increased up to 45 degrees. But B that will be operated till 24 hours, but that because of that one, the temperature will be operated up to the 85 degrees. Now, which one is more durable?
Battery
More stable? Battery A. Why? That will be operate for the less time, but because of that one, the device temperature will be increased only up to the 45 degrees. Okay, whereas the battery B that will be long lasting, that will be operated till 24 hours, but the problem is that because of using that battery my device temperature will be rise up to 85 degrees centigrade. Okay, and because of this high temperature the chances that some other component will be heated, and because of that heated they will damage. Okay, so I will work for 10 hours, but my temperature will be up to a certain range, so it will not harm other components. Okay, so I just say that battery A is more stable. Clear? Any doubt?
no sir.
Okay, now if we are talking about the form factor have a certain parameter that if you use any chip, so what is the physical size? Okay, what is the shape? of a chip. Okay, what is the layout of hardware? Okay, and last one is the compatibility with other components. Okay, fine. Any doubt? Now, what is the minimum of physical size is that you want to create a particularly device, like for example, earbuds. Okay, we are creating the earbuds with the smallest size so you can carry easily anywhere. Okay, but you place a battery or you place any chip that will be having a larger size. Okay, like for example, I think you are aware with the Arduino. Anyone? Or Raspberry Pi?
Yes, sir.
Okay, so you design a earbuds, but for that one you are using the Arduino. Is it feasible?
No, sir.
Because
No,
Arduino
sir.
is already that much high, that much size, so you can't basically use that Arduino for the earbuds. Okay, so physical size, then shape. The chips will be available either, like for example, you are seeing that 8-pin ICs, 16-pin IC you can see. Okay, this is the 16-pin IC. Or there are the other option is that you have this type of IC. Okay, so shape, then layout of the hardware is similar thing. Then compatibility with the other component. Compatibility means if you connect that particularly IC with some other IC, so they will be compatible or they will communicate. Okay, anything. Okay, like for example, you purchase one mobile phone. Okay, you have another mobile phone. In one mobile phone, you have a NFC, near field communication. Okay, and in the second mobile phone, you don't have that NFC. So is the NFC is usable for you? Obviously, no. Why? Because you can't transfer the data from one mobile phone to another mobile phone using NFC. Because one device has the NFC, but another device doesn't have any NFC. So that means compatibility with other component is done or not. On the basis of this one, we define one factor that is called the form factor. Okay. Third is the price. Price is also important because there are lots of competition in the market. Okay, you provide one product that will be available in the 1,000 rupees, that will be doing the same work, but other company will provide the same product in 700 rupees. Okay, so when we are going to design a system, we have to define the price is also an important factor. Same feature, everything is same, but they will provide in 700 and you will provide in 1,000. So in that scenario, your hardware will be basically, your product will be fail. You can't sell that one. You can create that one, but you can't go in market. Okay, then last is the power consumption, because power consumption is also important. If your device have a higher power consumption, that means you required a battery high. And if you increase the battery size, that means, sorry, if you increase the battery rating, so your size of the battery is also increases. Okay, so this is also a problematic. Okay, this is also a problematic. Okay, I think you are aware with the AA or AAA cell. Okay, AA will be providing the higher current as compared to AAA, so size will be also increases in the AAA. Sorry, AA. Okay, so if you if power consumption is high, that means you require a higher rating battery and your size will be increased. If your size will be increased, your hardware will not be a compact hardware. Okay, now nowadays what will be going on? We are miniaturize everything. Okay, previously the mobile phone will be the geometry box similar to the geometry box. Now it will be very compact. Okay, and some company will be creating a foldable mobile phone also. So they will reduce the size. Okay, and in that scenario, if you require, if your power consumption is high, so you can't develop a compact design, compact structure. So this is also a define the performance of the subsystem. Okay, fine, any doubt?
No, sir.
Okay. Now, if we are talk about the different parameters for the, so if I say the performance, okay, price, reliability, power consumption, price, reliability, power consumption, yeah, reliability or stability. Okay, and last one is the form factor. Okay, so basically this will be discussed about the for the charging subsystem. Okay, if I am talking about the charging subsystem, so what is the meaning of performance? Okay, initially we discuss what about these factors. Okay, now we discuss what is the meaning of this factor specifically for the charging subsystem. So if we are talking about the performance, so how fast charging is possible. Okay, just take one example is that you have a mobile phone. You have a original charger. Okay, now charge your mobile phone with the original charger. Note down the time period to charge from 0 to 100%. Okay, like this one will be the x1 time. Second thing, what you do, only change the cable. The power adapter is same, just change the cable. Okay, and again charge from 0 to 100%. The time will be the x2 time. Okay, always if you analyze that one, so x2 will be greater than higher. That means charging required, recharging time required when you charging with some other cable, adapter is same. Okay, so I am not changing the power rating because adapter will decide that what power it will be delivered to mobile phone. Okay, so I am not changing the adapter, I am only changing the cable. Once you take the original cable, once you take the local cable or any other company cable or any other mobile phone cable, and find the time period x1 and x2. Always x2 will be greater than x1. Okay, so the performance. Okay, if you are talking about the price, so the price, if you are talking about the price, so low budget. Okay, third, reliability, stability. Can it work with other adapter? or work with other cable, okay, or can it work with high power adapter? What is the meaning of high power adapter is? You require a 20 watt, you connect with the 100 watt. Okay, you require with the 20 watts, you connect with the 100 watt. What happens? Yes, what happens?
Oh, it will charge fast.
It will charge fast. How much time? 5 times?
Yes, sir.
Exactly this will be happen. Actually, this we want to be happen, but this is not true. Your mobile phone will be charged, I think, if it is with the 20 watt, if it's charged with the T1 time period, with the 100 watt, it will be time around 1.5 to 2 times T1. Okay, but it will be heat your bed. Okay, it will be providing heating. Why this will be happen? Just take one example. Connect one LED, okay, with some resistor. Okay, if I provide 2 volts here, I assume that 0.4 volt will be occupied here. So it will be operating 1.6 volt. Okay, the operating range of LED will be, okay, the voltage will be across that one is 1.6 volt. How much current it will pass? 2 minus 1.6 divided by some resistor R, that is the value of current. The similar question, second question, you I think you quiz to you attempted the second question, current I. 2 minus J 1.6 divided by R. This is the current. Okay. Now if this current is up to 20 milliampere, fine. Why? Because a LED comes with the rating current rating. Okay. If you provide the 20 milliampere, the LED intensity is higher. If you provide reduce the current, the LED intensity will be reduces because intensity is proportional to the current. Okay, but if you provide a higher current, 40 milliampere, what will be happen? The LED will be heat up and blast. Just simple example. Okay, now if you are talking about the 20 volt charger, so if you check 20 volt charger means 5 volt is the voltage and 4 ampere is the current. In the case of 100 watt charger, the 5 volt is the voltage and 20 ampere is the current. Your battery will be designed to charge with 4 ampere. You are providing a 20 ampere. What will happen? The chances of heat up, because you provide a higher current. Similar case, the LED will be operated 20 ampere, but you are providing a 40 ampere. Whatever LED will be heat up and blast. The similar cases, your battery will be heat up, and maybe the chances to blast. Okay, so the stability is that if you charge with the higher adapter, So we know that in that scenario, the battery will heat up, but the stability will be defined if your charging subsystem avoid the situation of heat. Okay, so this is also defined as stability. If you connect with that, it will be charged, but it will be avoid to blast. Okay, then one major question that will be arises: uh, what happen if your battery is short? Okay, along with that one, if high power, so similarly thing is that if battery is heat up. Okay, so these all things will be decide the stability. Okay, now the form factor. It will be decided that if you charge, so what type of port will we have? Is it compatible with other device? It is. Okay, if you, I think you are aware that initially in the Apple phone, the one lightning cable is coming. Okay, one lightning cable is coming. Okay, so the problem with the lightning cable or lightning port is that you only use that cable. You can't use other cable. Suppose, for example, I am in a traveling mode and I forget to carry my charger. Okay, so where I go, is it not compulsory that they also have the iPhone? So this is the problem that may arises when we are going with the not compatible system. Okay, we are going with the not compatible system. So that's why when you design a system, when you design a subsystem, it is an important thing that your system will be compatible. Okay, like assume that you have a different pen drive. Okay, one company will be the Kingston, one company will be the HP and everything. Okay, so you have a different company's pen drive. Okay, suppose the port USB port that are given that is not same for all pen. What happened in that scenario? Yes, what happened in that situation? You understand the question?
Sir, can you please repeat the question?
Okay. Like you have a different company's pen drive. One is having the HP, one is having the Kingston pen drive, and the port that are available in the pen drive is different. The size is different. So what are the issues in that?
It might not be compatible with the system.
Other all systems, it will be compatible with for one particular system, but it will not compatible with all systems. So the problem is the interfacing. if you want to connect, if you want to take the data from a system and suppose that system doesn't have that port, so you have to wait for that. Either you require some compatible device. Okay, so this is the problem. So every subsystem or every system when we create, the compatibility is important. So that will be decided by the form factor, packaging, compatibility, and all the things. Okay, understood the parameters?
Yes, sir.
Now, if I am talking about, like for example, we are taking some case. So the charging, if I think you are aware about that or not. You charge your mobile phone, okay? Everyone, I think. Just observe when you're doing the charging next time. Just observe that when your mobile phone will be charged between 0 to 10%, okay? The charging is very slow, 10 or 15%. In some scenario, 10% or some scenario 15%. That is given different from according to the different company. Okay. Now from 15 to 85 or 90% your charging is very fast. Okay, and after that, after 90%, again your charging will be slow. Have you observed anyone this type of charging?
Yes, sir.
If you are not done that one, just try it. Okay, just when your phone is completely 0%, connect your charger. Okay, on your mobile phone and note down the time. Okay, so if I'm saying that if your battery, mobile phone battery will be charged from 0 to 10%, it will be take around 8 to 10 minutes. Now 10 to 90%, it will be take around 45, 40 or 45 minutes. Then 90 to 100%, it will be again taking the 10 to 15 minutes. Just observe this thing now. Okay. So if we go with this calculation, if 0 to 10%, that means 10% it will take 10 minutes. That means 80% from 10 to 90, it will be take 80 minutes. But this is only taking the 45 minutes. Okay, if you are not observed that, you can observe next time when you charge your mobile phone. So basically the charging will be defined in the three different situations, three different conditions. Okay, or we can say that three different states. So one is the called the pre-charge condition. Okay, then constant current charging condition, and then constant voltage charging condition. Okay, before that one, I just take one more case is that everyone have the double A cell. Okay, if you have a multimeter at your home, okay, just observe the voltage for a new double A cell, and again observe the voltage discharged double A cell. Anyone try to check this one before that?
Inverter battery I have tested.
Okay, what is the voltage?
Initially, it is 12 volts. After a few years, it gets to like 10 volts or 11 volts kind of.
Okay, so the similar case is that if you are taking the double A cell, initially it will be the 1.8 volts. After discharging, it will be go up to the 1.5 volt, 1.8 or 1.6 volt. After discharging, it will be go up to the 1.5. Then it will be fully charged, it will be discharged. The voltage will be decreased 1.5, 1.8 to 1.5 or 1.6 to 1.2 volts. Okay, zero point 0.3 or zero point 0.4 volt. Now, what is the difference is created in between 1.8 to 1.5 volt? So, so my battery will not work. Okay, here it is for completely work and here it is a completely not working. So, what will be happening in this situation? The voltage, if you see that voltage is not too much vary. Only the thing is your current will be vary. If it will be 900 mAh battery, that means if the current is 900 milliampere, it will be go up to the 50 milliampere or 20 milliampere like that. Okay. So similar thing is happening in between for our mobile phone. Okay, if my mobile phone battery or any battery that will be rated at 4.2 volts. Okay, so if it will be having the 100% and 5000 mAh battery, if it will be go up to the 0%, it will be vary up to 3 volts, but this 5000 will be 0 amh. Okay, so the mainly effect is the voltage will vary from the higher range to low, little bit lower, but current is mostly there. So to charge this particularly, we classify our charging duration or charging will be in three different states. Okay, one is called the pre-charge condition, one is called the constant current charging condition, and third one is the constant voltage charging condition. So what is the pre-charging condition is that just with the same example, the 0 to 10% charging is called the pre-charging condition. The constant current charging condition is 10 to 90% charging. Constant voltage charging condition is around 90 to 100%. Okay. So if I draw the curve, so first is the pre-charge, second is the constant current charge, and last one is the constant voltage charge. Okay. In the pre-charge condition, what will be happening is your voltage will be increased slightly, as well as your current will also increase slightly. Okay. In the constant current charge, your voltage increase minimal but your current will be fastly increase. Okay, and that particularly is called the also called the fast charge. Fast or turbocharging modes are available nowadays in mobile phones, so they basically it is. Okay, in the constant voltage charging, in that one scenario, the current will be increasing minimal, where voltage will be fastly increased. Okay, so if I take the example that my 3 volt is there, okay, 0 milliampere. So in this state, if I say my voltage will be increased from 3 to 3.3. Okay, the current will be increased from 0 mAh to 500 mAh. Okay, just take an example that is not a correct data. I just take a little bit example. So that means you understand that voltage will be increased as well as current is increased, but both will be slowly increased. Okay. Now in this fast charging current, your voltage current will be increased from 500 mAh to 4500 mAh. Then voltage will be increased from 3.3 to 3.4 or 3.5. Okay, so voltage will be minimum increase, but current will be increased fast. Okay, and in the constant voltage, now the voltage will be increased from 3.4 to 3.5 to 4.2, and current will be increased from 4500 5,000. So current will be again slowly, but voltage will be increased fast. Okay, so this is an example, not an exact value. Okay, so this is only to assume that what is the three conditions. So basically, in this recharging, voltage and current both will be increased, but slightly. Okay, and the constant current, the current will be applied only. So that means current will be increased, voltage will be minor increase. Okay, and the third one is the constant voltage. In this, voltage will be increased only, current will be minimum. Okay, so if you draw the graph, so the voltage will be like that, then fast, then again. Okay, now if you see in the video, so the professor will be describing one particular graph. They will explain this type of graph. In the charging, the current will be constantly provided. Okay, so this is called the high recharge condition. The constant current will be provided. Okay, after that, when we it will grow, increase from pre-charge to the constant current, the current will be rapidly increased. Okay, so it is called the fast charge condition. Okay, and after that, when it will be go up to this one, now the current will be slightly start increase, and it will go zero when full charge. Okay, so this type of graph will be explained by the professor. Okay, so here some terms will be there. One is the high pre-charge, then I term charge, then I fast charge. Okay, so these three terms are there: recharge, fast charge, and term charge. Okay. This is called the term charge. Okay, where termination will be done. After that, your circuit will be terminated. One more thing is that current will never be zero. It is a minimum 50 milliampere or 40 milliampere. Okay, 50 milliampere. Okay, any doubt? But that current is not sufficient to do any operation. So because of that one, my device will be off. If I am having the mobile phone, if you are having an iPhone, okay, after discharge your battery, your mobile will be switch off. Okay, but after switching off your mobile phone, two operation will be working. One is your mobile phone is in findable condition. That means your mobile phone GPS will be working after switch off also. Okay, second thing is your mobile phone will be time updates. Okay, time updates or some other things, so that will be working. So minus current will be always there, so we can't say that the current will be zero, it will be minimum. And that particularly if we reach again that particularly point, it will be terminated. Okay,
Yes, sir.
now the point is that if I have a 4.2 volts, okay, and my voltage will be reduced up to 3 volts. Now what will be we are doing? So because if we are using the 4 volts, uh, like for example I apply the 4.2 volts, okay, on your display. I said that display will be work on more than 5 volt. Okay, so what should I do? I'm taking the example 4.2 volts is my battery voltage. I just assume that my display will be work on 5 volt, so I require one amplifier. Okay, that amplifier will provide the gain. How much gain is required? We apply the 4.2 volts, but we require the output voltage is 5 volt. So the gain is 5 divided by 4.2. Okay, because at this point, if I say this is the V out, so V out is 5 divided by 4.2 into 4.2. The input voltage and gain. So we are getting a 5 volt. Okay. Now for an example, if my voltage will be 4 volt, okay, so my gain will be 5 divided by 4.2, but now my voltage battery voltage reduced from 4.2 to 4 volt. So we are getting Vx voltage that is less than 5 volt. So in that situation, what will happen? My display will not work. Okay. So in that scenario, I have to set my amplifier gain is simply 5 divided by the minimum voltage. 5 divided by the minimum voltage. Like for example, my battery will be moved up to the 3 volts. Okay, so what is will be the my minimum voltage is 3. So this is my gain. Okay, so if I am getting 4.2 volt, I am getting output voltage V out that is higher than 5 volt. Okay, if I reduce my voltage, input voltage, my battery will be discharging and I will be get a 3 volts. In that situation, my V out will be equal to the 5 volt. Okay, so that means my V out will be either greater than, sorry, or equal to 5 volt up to, or V I can say my V out is always greater than or equal to 5. Is it clear? Any doubt?
Yes, sir, clear.
Okay. And now my device will be work on 5 volt. That means in every situation my device will be operative. No issue with that. The thing is that, like for example, you observe one case is, mm, if your battery is 2% or 5%, mobile phone battery. You observe one scenario is that your mobile phone brightness will be reduced. Okay. And second thing, if you observe that your speaker volume is also reduces. Observe that one.
Yes, sir.
Even the laptop also after 20% your battery screen brightness will be reducing. So what will be happening is that if I am getting the 4.2 voltage, battery voltage is 4.2 voltage. Okay, I set my gain in that way that I am getting a more than 5 volt. Okay, so what is my output voltage? I am getting 5 divided by 3 into 4.2 volts. Okay, this is battery voltage. This is the gain I set. So it is a 1.4. I am getting a 7 volt. If my battery voltage will be 3 volts, 1, so I am getting a 5 volt. So that means my output voltage will be lie between this. Okay. If I provide the high voltage, brightness will be high. If you provide only that sufficient voltage to on that display, so my brightness will be reduces. The same thing will be happen. So for that one, I required one amplifier because it is decided that I am using my battery that will be available up to 4.2. Mobile phone battery, if I am talking, that is 4.2 volts. That's it. Okay. If you are using any module that required more than 4.2 volts, you have to require an amplifier. And that amplifier will be designed with the help of op-amp. We already discussed the amplifiers. Okay, simple amplifiers we already discussed in week 1, week 2. So we designed the op-amp amplifier to amplify the voltage because my battery will be charged up to 4.2 volts. Okay, and my screen will require a 5 volt or 9 volt, so I have to boost my voltage. Okay,
Yes, sir.
now after that they will discuss the datasheet of BQ2404X. BQ2404X. So this is the battery charging module. BQ24040232. Okay. So, uh, anyone heard one thing is that in the electrical vehicles, which battery we are using? Anyone heard? If we are talking about the electric scooters, nowadays coming na e-vehicles, e-bikes, e-scooty. So which type of battery they are using?
Lithium ion it is, no?
Lithium ion. Okay. Any other? Only one is trying to do. Only you are there. Lithium ion is not there. Lithium ion is fine for mobile phones, fine for the earbuds, but for the e-vehicles, we are generally using the lithium polymer battery, LiPo battery. I think you heard or not. Okay, the lithium polymer battery. Now the problem with the lithium polymer battery is that you have to require a charger adapter for that. You can't charge anywhere. Lithium ion battery you can charge anywhere, no issue. Okay, you can charge with your mobile phone charger, like mobile phone will be having the lithium ion. Okay, you can charge with your mobile phone, you can charge with the other mobile phone if pin is compatible. Okay, but
Yes, sir.
lithium polymer, for the lithium polymer, it is not possible. With respect to every device, every battery, we have a separate charging module. Because charging balancing is mainly important in lithium polymer. If charging balancing is not there, there is a chances that your battery will last. Okay, so this BQ24040 is the LiPo battery charger. Okay, so in the starting, if you are heard that there are lots of the incidents will be happening that sorry, e-scooty will be blast because of charging. So that is only because of lithium polymer will be charged with a charger only. The charger module will be there. If you are not charging with that charging module, chances that the imbalance charging is there in LiPo battery and it will be reason to blast. Okay, so BQ24040 is the LiPo battery charger. Yeah, sorry, LiPo battery charger. In the LiPo battery charger module we required on charging IC, that is the BQ24049. So the professor will be discuss about this data sheet. That is all about the week 9. If you have any doubt, you can ask. Yes. Now, if you have any doubt, you can ask.
No, sir. No doubt in this.
So I think when you go through the more details, so probably in the next class we will discuss a little bit more. Okay.
Yes, sir.
Any other question?
So we will discuss about this IC in next lecture. Now, I think there are a few questions also related to this IC.
Yeah. You just go through with the week content first of all. Okay, and just read the data sheet of that one. In the next class, we will discuss that what is your queries about this particular part.
Okay.
Okay.
Yes, sir.
Anything else you want to ask, you can ask. No doubts?
No, sir, not related to these week 9. I have still watched the lectures.
Okay. So just go through with the data sheet also. So if you have any question in the data sheet, we will solve that one in the next class.
Okay. Also, I wanted to ask, like, I have not received my that ICs from the campus yet, so I'm having difficulty in doing the lab part.
You are not received yet.
Yeah, it
You
got
contact when you apply
yeah.
for
I have,
that.
16 October it was dispatched from Chennai, but not reached over here till I've complained a few days ago in the nearby station of the that courier office.
Mhm. What they are
So
saying.
I they have said given the contact number and to contact after 1 or 2 days.
Okay. Better that you can ask with the Victoria because Victoria will be confirmed with the suppliers. Okay. So
Yeah.
from their side, if they push,
Yes, sir. So I've uploaded only the that simulation part of it, like
okay,
the LT spec.
okay, fine.
Yeah, and
So if you just verify with the Victoria first, okay. If it will be received in 1 day or 2 days, so after that you complete your breadboard and then just upload the screenshot and PDF. Okay, I will consider that.
okay, sir.
That's why actually some student will be saying, so that's why I have not started the evaluation because if evaluation will be done after that, it is not possible to consider. Okay, so I am not sharing the evaluation sheet with the TAs till now. I am waiting that some more student will be uploaded because some students saying that the same issue they are facing also. Even though one student will be joining in the AES lab on 15th or 16th October.
Okay, sir.
So you just receive that one and send a message to me. Okay, what the Victoria will be saying and what when you will be receive the particular component. Okay, so
Okay, sir.
after 1 or 2 days, yeah, I will give you the extra time for 1 or 2 days, so you will do the Word part and submit the same folder because I think you upload the folder na? Link na?
Yeah, the link is uploaded. I have not uploaded the video of the
No,
breadboard.
or you uploaded the folder link or you uploaded the LT Spice file link.
I have uploaded the analog week one folder. In that inside
Folder.
there is all
Yeah,
solution and
okay. So basically you can drop it something here else na. So when you complete your breadboard, just upload the file also in that folder.
yes, sir.
Okay.
Yes, sir. Currently in batteries, I think they are using lithium ion battery only.
Nowadays, uh,
Yeah, nowadays.
EV, e-vehicles actually, but e-scooty will be using the lipo battery.
Okay, sir.
Just check. Previously, they are using the lithium polymer battery. Now they will replace because there are the lots of the problems are coming. The battery will blast.
Yeah, heat management was not according to the Indian
Yeah,
scenario.
heat management, charging subsystem is not accurate in that one. If your battery will be disbalanced, so when you charge, it will blast. Now they replace in some particularly scooters, they replace lithium ion with the lithium polymer with the lithium ion. Because lithium ion you can carry anywhere. Okay, like for example, your inverter batteries you have. Okay, you can carry any jerk, anything will be happening. It will be not blast. Okay, but lithium polymer is that if there are lots of the jerk, there will be chances to blast them. Now they
Yes.
replace
Okay.
lithium ion. I think I think Ola will be using initially starting. Ola will be using the hardware. Lithium polymer. But in the starting, they will try with the lithium polymer. Now the Ola will be transferred from lithium polymer to the lithium phosphate. Okay.
Yes, sir.
Okay. So thank you.
Thank you, sir.